All right, so we are going to work on the second day of U substitution, and today we're going to have definite integrals. So we will have an upper and a lower limit on our integrals. So this is going to be topic 6.9, day 2, and we're going to be talking about U substitution for definite integrals. All right, and so we're going to do very, very similar to yesterday, except the last step where we would go ahead and change u back to x. We're not going to do that with definite integrals. So to complete most efficiently, we always like to be efficient. What we'll do is write the upper and lower limits in terms of u. All right, so we'll have like u is equal to x squared plus 1. And so if your upper limit is like 7, you would have to put that's an x. You'd have to put that 7 in for x. And then you have it in terms of u, which is going to make this a little bit smoother and quicker. All right, then, whoops. Also, leave the antiderivative in terms of u when applying the fundamental theorem of calculus. All right, so that's when you plug in your lower and upper limits and subtract. We'll go ahead and leave all that in terms of u. So let me show you what I'm talking about. So for example 1, we're going to evaluate. And a is the integral from -1 to 1 of x times the quantity x squared plus 1 quantity raised to the 4th dx. Okay, so when you see that there is an inner function, we know we need to do u substitution. So first we'll figure out what the inner function is, and that's going to be u. So in this case, u is going to be x squared plus 1. Right? Then we'll find the derivative of that and solve it for du. Now we're ready to correct our integrand if we need to. So we need 2x dx. What we have is x dx. So what we'll do is we'll multiply by 2, and then outside the integral, we'll multiply by 1/2. Okay, so now we're ready to write in terms of u, and it's everything that we're going to write in terms of u. So that's including our lower and our upper limits. So what we're going to have to do, they are x's, and what we'll have to do is plug them in so we can change them to u's. So that means the -1, we're going to square it, and we'll get 1, and then add 1 to it, and that's 2. Right? We'll do the same thing for the upper limit. We're going to square it and get 1, add 1 to it, and get 2. Okay? In the place of x squared plus 1, we're going to put that as a u. And then in the place of 2x dx, we're going to put that as du. Okay, so now we're ready to find the antiderivative. All right. Well, actually, in this case, we don't have to, now that I look at it a little closer. What rule do you guys remember if we're doing a definite integral and the upper and lower limits are the same? Whenever you have that, the answer is going to be 0. Okay. So if you notice that, you do not have to find the integral. You can just go ahead and say that it equals 0. Okay, so let's look at another one. We'll actually have to finish it up. So for b, we have the integral from 0 to 2 of a fraction. The numerator is x squared. The denominator is the square root of x cubed plus 1. And then we have our dx. Ooh, this one's got a lot going on. All right, so let's just go ahead and figure out what our inside function is. And the inside function is going to be what's under the radical, which is going to be x cubed plus 1. All right, the derivative of that is 3x squared. So du should be 3x squared dx. All right. And then we're going to need to correct our integrand. We have the x squared, but we need 3x squared. So we'll multiply by 3 on the inside, 1/3 on the outside. I'm going to go ahead for the square root and write that as raised to the 1/2. All right. So now we're ready to write all the things in terms of u. So we'll take 0 and we'll put it in. We're going to cube it and add 1 to it. And then same thing with the 2. Cube it and add 1 to it. Okay. All right, and then that 3x squared dx, we can write that as du. And put a 1 up there. And then that would be u to the 1/2. Right. So now we need to fix that one more time. So that I would want to write that as u to the negative 1/2. Okay, so now we're ready to find the antiderivative. So that 1/3 is going to hang out. Okay, so we're going to add 1 to negative 1/2, and that our new exponent is going to be 1/2. And we would divide by 1/2. So whenever I have a new exponent that's a fraction, instead of dividing by the fraction, I'm going to multiply by the reciprocal. All right, and then I would put my lower and upper limits on the bracket. All right, I wrote that a little different than I normally do. Sorry, I usually only do a bracket on one side. Okay, so now I'm ready to plug those in. Now, because I changed them to U's, I just go ahead and plug it in with U. I don't need to go back to X. That would make it a lot more complicated. So I would put the 9 in first, and then minus, then I would put the 1 in. Okay. We could have made this a little easier for ourselves. I didn't do it, but we could have pulled that 2 out with the 1/3. That would have probably been smarter. So like at this point, we could have pulled that out and made it 2/3 out there. I didn't do it, so I'm just going to keep going with what I have. But 9 to the 1/2 is 3. And then 1 to the 1/2 is 1. So that's going to be 6 minus 2 is 4. And then when I multiply 4 times 1/3, 4/3 ends up being our final answer. Okay, so that's U substitution with definite integrals. All right, we're going to do a couple more. For C, we have the integral from 0 to pi of the cosine of 2x dx. All right, so our inner function is 2x. The derivative of that is 2. So du is going to be 2 dx. I don't have the 2, so I'll multiply by it and then counteract that by multiplying by 1/2. All right, then I'm ready to change over to u. So I'm going to put 0 in. 2 times 0 is obviously 0. Put pi in. 2 times pi is 2 pi. And then it's going to be cosine of u du. Okay. That 1/2 is going to get multiplied by the antiderivative of cosine of u du, which is going to be sine of u. And then we're going to use the fundamental theorem of calculus. So I'll let that 1/2 hang out. And then I will put 2 pi in. And then I will put 0 in. All right. The sine of 2 pi is 0. The sine of 0 is also 0. So this one ends up equaling 0 for our definite integral. All right, one more. We have the integral from 1 to 4 of, we have a fraction. The numerator is the natural log of x squared. The denominator is x, and then we have dx. So this one is different. So a lot of times on these fraction ones, I tell you that a lot of the times the denominator is u. The denominator is the inside function, but that's definitely not right on this one. So it's not always that way. So think about it for a second. The inside function in this case is actually going to be the natural log of x. And the derivative of the natural log of x is 1 over x. So du is 1 over x dx. And we already have that. So this could be rewritten as the integral from 1 to 4 of the natural log of x squared times 1 over x dx. So if I multiplied those together, I would get the original integrand. So I don't have anything to correct. I can go ahead and plug in. All right. So I would plug the 1 and the 4 in for x, which is going to give us kind of a weird lower and upper limit, but it's going to be okay. Hang in there. All right. In the place of natural log of x, I'm going to put u. And then in the place of 1 over x dx, I'm going to put du. Okay. Then I will use my power rule for integration and add 1 to my exponent and divide by it. And I'm going to evaluate that from the natural log of 1 to the natural log of 4. All right. So that 1/3 I'm just going to let hang out in the front. And then I'll plug in the natural log of 4 minus, and then I'll plug in the natural log of 1. Now, the natural log of 4, we don't have the ability to figure that out in our heads. But the natural log of 1 we do. So it's like asking yourself, e to what power gives you 1? So that power is 0. And 0 cubed obviously is 0. So our final answer should be 1/3 times the natural log of 4 cubed. Okay, so what I want you guys to do for your assignment tonight is the back side of the worksheet we worked on the previous lesson. So it's going to be 13 through 22.